This is our fourth lecture in the series to learn about the electrical power plant engineering and the power system engineering. And the first lecture, what we saw about was the different power plants, like it could be based on the conventional sources of energy, like the solar power plant or the solar based power generation, and it could be based on the wind power, and then there could be the conventional sources of energy was this, and the conventional sources of energy, like the coal based steam power plants, the nuclear power plants, the diesel power plants, thermal power plants, etc., based on coal. And again, there could be hydro power plants. So based on this, the power energy which was generated was being transmitted using the transmission lines, and then there was a distribution happening, and there could be the step up transformer which is being used to step up the power, and the transmission line is being used to transmit the power, and then there could be the step down, and then there could be the utilization. So all this was the power scenario, like how the generation was happening. And what we are studying about is the power plant engineering, which is based on the different power plants. So these are the generating stations where the power is being generated. So the power is being generated somewhere in the generating power plants, and then now you will have to transfer it, and it is being transferred also. And after that comes the power plant economics. So this deals with the different factors which will help you to understand the operation of the power plant, and which will help to optimize the operation of your power plant in an economical way. And it will also help you in planning, so that you can planning as to how much power plants you need to have for a specific area, where by knowing the demand or total requirement of the power for that area, and again you will have the demand or the kilowatt of the power utilization during a period of time, like a period of day or a period of year, which will give the different load curves for the period of daily load curve, monthly load curve, or yearly load curve, which was helping you to identify like what was my demand and what needs to be the capacity of my power plants which I needs to install, or which I needs to develop or construct. And again, if I'm having one power plant of 300 kilowatt, and if my generation demand is for the average power is close to 400, then I need to have a standby power plant of 100 kilowatt, which could be needed. Or if my peak power demand is 400, then I will need a standby power plant of 100 kilowatt to meet the peak load, or I will need to borrow it from the grid, etc. So again, as you can see, the load curve is one of the curve which will plot the graph of the kilowatt utilization of the power with the time. So that is a kilowatt hour graph. And again, there is the graph of whatever is a connected load to the whatever is connected load to the whatever is connected load to the grid or the transmission network or the system of the power plant. So you will have the generating station, then you will have the circuit breakers, then you will have the step up transformer, then you will have the transmission line. The transmission will usually happen in the range of 400 to 1000 kilovolt, and the generation is happening at 11 kilovolt range usually. This is just an example case. And again, you will have the step down transformer, and you'll have the substation. Then the step down transformer is possible, and the step down and the utilization will happen in the range of 400 volt. That is a line to line voltage, and if you will take the line to neutral voltage, it will be close to 230 volt. So at 230 volt, if you see whatever is my connected load, it could be a house, and if you go into the house, your connected load could be 4 television, or for one television, 2 or 3 fans, one refrigerator, one AC, and all this could give a connected load close to 1000 to 2000 or 3000 watts. So again, this will give your demand for a single house. If you take, and if you take a large city, there will be thousands of houses, and again there will be some power which will be directly taken from the substation, which will be used to supply to the industries, which will be taking power in the range of kilowatts, like 11 kilowatt, 3.3 kilowatt, or 33 kilowatt, etc., can be directly needed to run large machines of the industry. So all those things will give the total connected load, and if you sum all the loads which are connected to the power system, it will give the load requirement in kilowatt. And when this connected load is plotted with the usage which is happening. So suppose if you are having a house, then during the daytime you need 4 number of fans, 5 number of lights, etc. And in the night time the load will reduce, like you will need a 3 number of fans, and you might not need the lights, so your load will go down, and your television may not be on, your one AC may not be on, etc. Like depending on the period of day, as you can see, the requirement of load in even in your house is going to change. In a similar way, in the factories would be operating at their peak capacity during a specific time, like a production could be happening. Most of the companies, the production could be happening at the peak capacity during the night time, as electricity could be cheaper. Example, there could be certain routines of production, etc., which could give a peak load demand for even the industries. So such kind of situations give rise to a peak load demand. So during that period the power consumption could go high. Like if you see, the power consumption without any industries in a city could be high during the period of the day, like most of the people would be working, most of the fans, electric lights, TV, television, everything would be on. So that could give rise to a peak load time during the period of a day. So again, that will vary with the night. So there will be the average load which you will need, that is average of the total loads which you are having, hour wise or minute wise. If you are taking for the period of hour wise, if you are taking for the period of one day, and it could be it could be similarly made for period of month, period of year, etc. So that was what was giving a load curve, and I explained it in detail, and also explained it in last lecture. So again, moving further to the load curve, some other terms which we will discuss further in this lecture is that the demand is the total kilowatt hour drawn from the supply, as I said. And again, the maximum demand, which I said that the maximum kilowatt hour can happen during any period of the day. Also it can happen during the period of month, like a period of month, a specific period of during that month you will have more load demand. And again, it can be graphed. If the graph is made for a period of year, again you will see that during the specific period of year, like during the summer, the power consumption could be higher than the winter, as more people would be needing ACs and the other kind of facilities to do the cooling. So the power requirement could be higher. So again, if you are plotting that for a period of year, again the peak load would vary for that time, and the curve usually has a peak load, and again it comes or goes by the average load. So that's how the load will vary, and it's known as the load curve. Again, the demand factor is another important term, which is the maximum demand divided by the connected load. So what was your peak load divided by your connected load is known as the demand factor, or again it is known as the load factor. So the average load is the area under the load curve divided by 24. So that was the average load factor for a period of one day. So how much was your total power demand during the period of a day? That was in kilowatt, and if you are multiplying that by hour, that will become the kilowatt hour. And again, if you are dividing that by the period into concentration, that is 24, then that will give you the average load. And then the load factor was the average load divided by the maximum load. So you saw the demand factor, you saw the average load, and you saw the load factor. So it is always desirable to have a load factor as small as possible, as I said in the previous lecture. So it would have your peak load very close to your average load, so that there is not much requirement of an excess power. And even if the excess power is required, it would be in a very small quantity, which can be met from the connected grid or a standby power plant. And the construction of the power plant. So the cost which goes into the construction of the power plant would be like, there would be the cost of the land which you are going to purchase, there would be the cost of the construction of the building, the equipments which will be like the generators, the power, the boilers, and the full set like the turbines, etc. you need to set up. So all that will have a capital investment. Then again, if you are a large private company, then you would be taking some kind of a loan from the bank for the construction of the power plant. So you'll have to pay the interest on that amount. So you will also have to consider that in the cost of the power plant. Again, there would be the depreciation. like as the age goes on for your power plant, the value of the assets will have to go through some kind of depreciation. So again, you will have to consider that. Again, there will be the insurance cost for the equipments which you are insured, which you would have to pay on a yearly basis, monthly basis, whichever. And then there will be like the people who are working in the organization, everything will have cost, and there will be the fixed running cost like the fuel cost, etc. So these are the different costs. So all this will have to be considered while you are going to bill the customer for the amount of units which you are which he is consuming, or per unit of electricity which you are supplying. So there were different rules for the pricing of the power in different states and different countries, etc. So I'm not taking this by taking a specific example of a country like India or any other country, but I'm taking a general way, like how the pricing of how a company could or usually prices the power by taking the general form rate method. So the tariff for an electrical energy is the total cost. It depends on the total cost of generation and the profit. So what was your total cost of generation? So the total cost of generation, while considering the total cost of generation, you will also have to take into consideration what was the total cost of the construction of your power plant, the depreciation, the interest, the fixed running cost, etc. And how much profit do you want to add into that, so that it can be added to the power you are supplying. And again, the tariff could be different for a domestic consumer, again it could be different for a commercial and industrial consumers. So again, the general form rate, as you can see, is equal to Z equal to AX plus BY plus C. So Z will be the total amount of bill for that period. So this is taking the general form rate method, and X will be the maximum demand in kilowatt, and A is the rate per kilowatt for maximum demand. So if you are a consumer and if you are having a maximum demand of like 1000 kilowatt, and if you're having maximum demand of like 1000 kilowatt, and your average demand is close to 400 or 500 kilowatt, then you would be billed a specific amount for the maximum amount of demand you are producing. And then there is a B, that is the energy rate in kilowatt hour, and Y is the energy consumed. So based on the maximum demand which you have produced, like if you are consuming 1000 kilowatt hour and you have a maximum demand of 50 or 60, anything it could be. So based on your maximum demand, there could be a specific percentage rate which could be added, and based on the total units which you have consumed or total power which you have consumed during the period of the operation in kilowatt hour, like the period could be 1 month, could be the time during after which you are being billed. So during that period of 1 month, that is equal to 30 days into, if you are considering 30 days, then the 30 days into 24 hours, that is a period of hour if you are converting that. So into the number of units which you have consumed, or the number of watts which you have consumed, if you consume 1000 watts during this period, so that could give you a kilowatt hour. So, and again, the energy rate per kilowatt hour, so that is 1 kilowatt hour, it could be 1 unit, or 1000 kilowatt hour is usually 1 unit. So again, it could be based on what is the rate per kilowatt hour, and plus there could be a constant rate which you could add based on the profit etc. Cost of generation. So that is the general form. And again, there could be a straight line method which is equal to the cost could be equal to BY, that is B is the energy rate in kilowatt hour, and there is a per unit energy rate into number of units or number of kilowatt hour you are consumed. So there is nothing like a maximum demand, and there is nothing like a fixed cost. So again, there could be only like energy rate based on the kilowatt hour plus the constant C. So these are the different ways. So this was a lecture about the power economics. So what you saw about was the load factor, the demand factor, and again you saw that what all kind of fixed cost and the different kind of cost could come on the power plant, and again how is it possible for, or what are factors or whatever method, like you saw just a general form of rate method, during which it was possible to like compute the rate which you are going to bill to the consumer per unit or per kilowatt hour of energy which is consuming. So again, this is a series of lecture about the power plant engineering and the power system engineering. So you can find the full link of all the videos in this series or the playlist in the description. Also, I have added the playlist related to this. There is other uh, topics like the electrical generator, the transformers, the power systems, etc. in the description. So if you like to go through, you can look into that. Also, if you like this video, please do subscribe. Also, do share with your friends. And if you want any specific topic to be discussed, please do mention that in the comments. That's all. If you like this video, please do subscribe.